Section 1.3, Complex Numbers, Part 5. We want to solve quadratic equations in the complex number system now. So that means we want to find solutions. When you solve, you're finding solutions. And recall that when we find solutions, we put them in the curly brackets, the solution sets. So we need this definition first. When we have the square root of a negative, we can break that apart now. -1 times whatever we have under the radical, because we have a definition for -1, the square root of -1. That is I, the imaginary unit. So we can continue with our simplification and say that the square root of -1 is I. So this is the process we'll go through when b squared minus 4ac is a negative number. We'll continue to simplify by factoring out -1, taking the square root of -1, and changing that to its other name, which is I. So let's first look at how we're going to just do the square root part. So say we've worked a problem and we get down to the square root of -12, or -12 is our b squared minus 4ac. So what we just saw in that definition is break out the -1. But we've also learned to look for the largest perfect square factor in the number. 12's largest perfect square factor is 4. So we factor this to -1 times 4 times 3 so that we can take the square root of -1 and take the square root of 4 and leave behind the simplified radical square root of 3. So we end up with 2i square root of 3. So you'll notice what I did put the I second. We normally would put the number 2 in front of the I, even though I had the I and the 2 here. We would switch it for our final answer. Instead of I, 2 square root of 3. Convention has us write it 2i square root of 3. So now let's solve in the complex number system. Here is a quadratic equation. However, it's not in standard form. We'll get it in standard form by subtracting 6x from both sides. And now let's identify a, b, and c for our quadratic equation. And first let's analyze the discriminant. What is the character of the solutions for this quadratic equation? Well, b squared minus 4ac would give us -16. So that tells us that the character of the solutions will be two non-real solutions that are conjugates. So repeating what we had, I've just repeated it here on this slide. We had that quadratic equation, we had a, b, and c identified, and we've already computed b squared minus 4ac. So plugging that into our quadratic formula, so x equals -b plus or minus, and I already know what the b squared minus 4ac is, so I've put that in, -16 all over 2a. 6, so that becomes +6. Under the radical, square root of -1 is I, square root of 16 is 4. That's where I get the 4i, and 2 times 13 is 26. But now I see I have all these even numbers in this problem, so I'm going to factor out a 2 in the numerator and a 2 in the denominator so that I can then cancel these 2's and write the more simplified fraction of 3 plus 2i over 13. But remember, this needs to be in a plus bi form. So I've got to break up that fraction for my solution set. So I have 3 over 13, that's the real number part, plus, oh, I see I forgot my plus. This should be plus or minus, right? Plus or minus. So my first solution is 3 plus 2i over 13, or 3 over 13 plus 2 over 13i. And my second is 3 over 13 minus 2 over 13i. Notice that they are conjugates of each other, and they are complex numbers in a plus bi form.